This is Miss Hughes.
Hello, it's Mrs. Flynn,
And Miss Hughes.
and we're here today to talk about more inequalities. But there's something different about this inequality as the day before.
Yeah, okay, so let's start with the one on the left.
Notice that you have a variable on both sides of your inequality.
Okay, as we said yesterday, we can start by just treating it as we would an equation. So should we try and get the f terms on the same side?
Okay, so I'm just going to decide that I'm going to choose and subtract 6f from this side. If I subtract 6f there, I'll subtract 6f here.
Okay, so on the left, I end up with minus f minus 3 less than minus 15.
All right, and now I'll add 3 to this side, add 3 to this side. I have negative f is less than negative 12.
Good.
Now, how do you get rid of this negative in front of the f?
Well, this is the really tricky. Now, if that were a normal equation, I guess we would just multiply both sides by negative 1. That would get rid of the sign.
Another thing you could do is, sometimes I think about it as this is multiply negative 1 times f, so to undo multiplication, you could do division.
That would work as well.
Either way.
Yeah. So we would end up with f. So if we say we divide both sides by negative 1, let's see what comes up.
Now, we need to talk about this because something happens when we divide by negative 1. And we can think about this. So negative 12 divided by negative 1 is 12. We can think about this. We'll just do a little side note here and we'll erase it. If I had the number 2 is less than 7, do you agree with that?
I agree. Yes.
Okay, well, I'm going to multiply both of these terms by negative 1.
Okay.
Okay, so I multiply by negative 1. Multiply by negative 1. So I end up with negative 2 is less than negative 7. Do you agree with that?
I don't agree because that's wrong. Minus 2 is greater than minus 7.
That does not make me happy because it is not right. So what happened here is if we multiply by negative 1, then our inequality would switch to be negative 2 is greater than negative 7. We could also say, well, what happens now if not we just didn't multiply, maybe we divided.
Okay.
So we had, let's see, 2 is less than 7 again, and let's divide by negative 1. Divide by negative 1. So now I have negative 2 is less than negative 7. Is that correct?
That's also false.
No. So that means when you're dividing or multiplying by a negative, so we could write a little note here, divide or multiply by a negative number, our inequality switches.
Oh. And that's always true?
That's always true.
And does it matter whether it's by minus 1 or just any negative number?
It will work for any negative number. We could divide this by negative 2, divide this one by negative 2. We would have negative 1 is, fill in the blank here.
It's going to be...
This then negative 3.5.
So it's going to be greater than.
Yeah.
Excellent.
So therefore it works with any number.
Okay.
Okay.
And so this is kind of the only little twist about inequalities, isn't it? Other than that, we can treat them like normal equations most of the time.
So I'll go back over here and just fill in that last bit. So now we divided by negative, so our inequality switched. F has got to be greater than 12. And to finish off, we have our number line here with 12. Can it be equal to 12?
Nope.
Nope. Open circle. Greater than 12, this direction.
Good. And just to point out, there's some people in my class who have a clever little trick. So if we go back to the first step, we chose to subtract 6f from both sides so that we would collect all the terms on the left. If we had subtracted 5f, because 5 is smaller than 6, we would have ended up with a positive f term. We would have ended up with f on its own. So that might be a way. Yeah, that might be a way to avoid the negative.
Yeah. All right, well, let's just go ahead and cruise through these next problems. It's a good idea for you to press pause on the podcast and try working them yourself and then checking with us.
Good. Okay, so let's start by simplifying the left-hand side, tidying up, collecting like terms.
So k plus 6k, we have 7k. 10 minus 12 is minus 2.
And on the other side, we've got 4k minus 2k is 2k.
All right, now to move some things around.
Yep, just like in an equation. So let's subtract 2k from both sides.
Okay, so now I have 5k minus 2.
Oh, and there's nothing on the other side. How do I write
that?
Nothing.
Zero. All right, so now add 2 here. Add 2 here. 5k is greater than 2. Divide by 5. divided by 5. K is greater than 2/5.
Good. And I don't need to switch anything around here.
No, because we didn't have any dividing or multiplying by a negative.
Excellent.
So if we look at our number line here, we have 2/5. Open circle or closed circle?
Open, because it's greater than, not including.
And it's greater than, so we're going this direction.
Super. Okay.
Next
Is
one.
there another one? Oh, just a little difference. There's some brackets there. So are we going to distribute the brackets
We will
to start with?
distribute first. So we have 12r minus 19 is greater than, we haven't changed anything yet.
No.
Distribute this.
So minus 7 times 4r is minus 28r. And then minus 7 times minus 3. Oh, we need to be careful with the signs. They're positive.
It's a
Yeah,
positive
21.
All right, so now I'm just going to add 28 here.
Yep.
And add 28 here. Now, it doesn't matter the steps as long as you have to make sure that you're following the correct order, I guess.
Yeah. Okay, so 40r minus 19 is greater than 21.
Okay, plus 19, plus 19. Now we have 40r
Is it
greater than,
40.
well, that makes it nice and easy.
Yep, divide by 4, 40.
So r is greater than 1.
1. And again, I don't need to switch anything because I've divided by positive
And we
numbers.
still have a lot of open circles here.
Yep.
So we have r is greater than 1, open circle greater than. All right,
Yep.
that's it for now.
That's done.